Today I want to talk about the concept of slope, and most of us have heard the word slope before. We think about ski slopes, we think about the slope of a golf green, you think of a driveway. Typically we think of a hill as having some kind of slope or some kind of slant. We also talk about slope if something is straight up and down or if something is flat, and we'll get into that later. A good definition for slope would be a ratio, which you recall is going to compare two things. A ratio that describes the steepness and direction of an line. A ratio that describes the steepness and direction of a line. And what we mean by that is this. Is it steep? Is it really up and down, or is it flatter? And by direction, is it going up or is it going down? So looking at it from left to right, is it going up or is it slanting down? So that's kind of what this ratio tells us. And the way we write this ratio is a couple of different ways. A lot of times we say rise over run, or we'd say it's the vertical change divided by the horizontal change. So how much the graph changes up and down compared to how much it changes side to side. So let's take a line, look at a line, and let's say, well, let's find the slope of this line. Well, first we want to see the vertical change because that's in the numerator. So this starts up here at 1 and goes up to 3, so it changes. Oops, graph's not working very well. Well, let's see if I can use a different color, make it work here. It changes from this point to this point. Okay, so we're trying to go here and we're trying to meet this line right there. We're trying to meet it. So what we would say is it changes by 1, 2 going vertical, okay? And then the horizontal change will start right here, and we'll start 1, 2, 3, 4. So it changes up 2 and it changes right by 4. So what we'd say is that our slope for this line is 2 over 4. Again, every time we go up 2, we go right 4. We go up 2, we go 1, 2, 3, 4. And look, we're still on the line. Up 2, 1, 2, 3, 4. And look, still goes in our line. And we could also reduce that, as you know, and make that 1/2. So you could also say for every time we go up 1 over 2, up 1 over 2. Now, some of you may be saying, well, Mr. Antonio, what if we went down? Okay. What if we started at the top point and we went down to the next point? Well, if you started here, you'd go down 1, 2. When you go down, that's -2. And if you go to the left, that's going to be -1, 2, 3, 4, -4. So you'll have -2 over -4, which is the same as what we had before. -2 over -4 equals 2/4, which is 1/2. So no matter how you look at it, the slope will still be the same. So for every time the graph rises by 1 on the y, it moves by 2 on the x. Let's take a look at the next problem. Okay, let's take a look at this graph. If we start at this point right here, let's move to the other point. We go up 1, 2, 3, 4, 5, 6. So we go vertically 6. That's our rise. And how much do we run? Well, we go 1, 2, 3, like that. So the rise over the run. Again, that's the ratio, so we put that, so we'll say 6 over 3 is the rise over the run, which reduces to, divided by 3 is 2, divided by 3 is 1. We could say our slope is 2 over 1, or we could say that our slope is 2, and that's understood to be over 1. What that means is every time our graph moves up 2, it goes right 1, up 2, right 1, up 2, right 1. Or we could act like these were both negative, and you'd go down 2, left 1, down 2, left 1, down 2, left, down 2, left, and on and on and on. Again, all slope is it describes the change in y, change in the y-axis, and the change in x. So that's it. Vertical change compared to the horizontal change. Let's look at this last one. Now notice these two graphs go up, going to give us positive slope. This one slopes down, which is going to give us a negative slope. So if I start at this point, I'm going to go 1, 2, 3, down 3. That's my vertical change, -3. And I'll start here and go right 2, 1, 2. Okay, So my slope, my vertical change is 3 over 2, and there's my slope. If, let's say I did it the other way, and I said, I started from the bottom point, I would say, well, I went up, let's see, 1, 2, 3, vertical change is 3, left it goes 1, 2, that's negative 2. It's rise over run, so it'd still be 3 over negative 2, which gives me the same. Again, you could think about this in two ways. Let's start at this point. Every time you go down 3, you go right 2, down 3, wait, 1, 2, 3, right 2, 1, 2, 3, right 2, and it keeps going. Or you could look at this and say, oh, it's 3 over negative 2. So every time we go up 3, 1, 2, 3, we go left 2, up 3, left 2, up 3, left 2, up 3, left 2. It's the same slope. And again, what does this mean? If you have a positive, if it's negative in the numerator, it means it's going down. If it's positive in the numerator, so if you had 4 over 7, that will be up and to the right. If it was negative 4 over negative 7, that's down and to the left. If you had 2 over negative 3, 2 means it rises 2 and then goes to the left. If you had negative 3 over 5, that will be down and to the right. Again, the positive and negative tell you which way it goes, up or down, left and right. But it's always the change in y over the change in x when we're talking about slope. Now, I want you to look at this graph closely again as we wrap up today's lesson. Is there a way to tell what the slope is just by looking at the ordered pairs? Look at you. You got 6 and 2, 3 and 1. I'm going to write them right here. You have ordered pair 6, 3, and you have the ordered pair 2, 1. Well, what do you notice? If you subtracted 3 minus 1, you'd have 2. And if you subtracted 6 minus 2, you'd have 4. 2 over 4, 1/2. Because think about it. If it's the change in y, it's the change in these two, which is 2, and then it's the change in x, which is 4. Let's see if it works for this graph. Look at 9 minus 3 is 6. 8 minus 5 is 3, which is 2 over 1, which is 2. So what you can do is you can take your ordered pairs and simply subtract the y's and subtract the x's. So I can say 9 minus 3 over 8 minus 5 equals 6 over 3, which is 2. Okay? So I think it's pretty cool. Again, let's take a look at this one. This is the ordered pair 3, 1. This is the ordered pair 1, 4. Let's subtract the y. So we have 1, 4, and we have 3, 1. Well, you subtract the y's first, so it's 4 minus 1. And subtract the x's, 1 minus 3. 3 over negative 2. And there's my slope. What we call this is the slope formula. And I'm going to put it right here. And we'll finish with this, and we'll talk more about this later. It's the change in the y's over the change in the x's. Now, since we need to know which ones to do, we typically say this. We label these. Erase those, make them a little bigger. So we have the ordered pair 1, 4, and the ordered pair 3, 1. This is x and y. This is x and y. And we're going to call that x1 and y1 just because it's the first pair. And we'll call this x2 and y2, which is the second pair. So typically we say y2 minus y1 divided by x2 minus x1 is our slope formula. Now honestly, it doesn't matter if you changed it to be y1 minus y2 over x1 minus x2. The 1's and the 2's just have to match up. Now, this is kind of weird, and we'll end on this. We use the letter m to tell us what our slope is, which is kind of random and weird. So what we say, if our slope is 2, we would say m equals 2. Our slope is 2. If our slope is negative 3 over 2, we'd say m equals negative 3 over 2. There's your lesson on slope. We'll talk more about this later in class.